Yes, good morning all of you. In the last class we completed a solid state the full concept, and from that solid state whatever exercise questions will be there, go through that one, try to solve it. Okay, you are very well and good, otherwise send WhatsApp to me, I will solve it and give it to you. Okay, now we are going to discuss about the second topic in the second PUC is nothing but solutions. Usually weightage for the solutions is nothing but 7 marks as like solid state. Out of 7 marks we are getting 1 5 marks question and we are getting 2 1 mark questions we are getting. This is the weightage of the solid solutions. Okay, this is a very important both theory as well as competitive point of view, and already around 50% of the solutions topic you learned in the first year under some basic concepts of chemistry. So all concentration methods again we are discussing here. Almost 50% of the around 50% of the topic will be covered. Okay, we will see one by one. First of all, we are taking some example. You see carefully. First of all, I am taking NaCl in or dissolved in water. So basically, if you take NaCl in water, I am telling we are getting solution. If you take the another composition, nothing but sand dissolved in water, I am telling we are not getting solution. Why? What the difference here? If you take NaCl is a solid substance and water is the liquid substance, if you mix them, we are getting finally solution. Why? Because means if you take like that, we are getting a uniform mixture. We are getting uniform mixture means is calling as a homogeneous mixture. We are calling homogeneous mixtures. We are getting such kind of homogeneous mixtures only we are calling as a solution. Means after dissolving, can you identify this is a salt particle, this is the water particle? No. Such kind of uniform distribution of the particles we are calling as homogeneous mixture. Such only we are calling as a solution. But you see here, sand is a solid substance, water is the liquid substance. After mixing them, we are getting any uniform mixture? No. The sand particle will be settled down and water will be like this. This is the which particle? Sand, and this is water particle. Means after mixing, can we means is it giving uniform mixture? No. We are observing or we are identifying its constant particle. Such mixtures only we are calling as heterogeneous mixtures. Those heterogeneous mixtures is never calling as a solution. Okay, are you getting or no? Now I will write the definition for this one. What is the meaning of solution? So generally I am representing this one always like this. What is the meaning of solution? This is only calling as solution. Can we do the explanation? Homogeneous mixture. Homogeneous mixture of 2 or more components. 2 or more components. 2 or more components. And which are not chemically reacted. Such kind of homogeneous mixtures only we are calling as a solution. Once you can see, homogeneous mixture of 2 or more components which are not chemically reacted. Just you see carefully, NaCl you are dissolving in water. Is there any chemical reaction between them? No. Just what happening here after dissolving, it's becoming like Na plus particles and Cl minus particle. Are you getting any new products? No. That's why. So homogeneous mixture of 2 or more components which are not chemically reacted, such kind of homogeneous mixtures only we are calling as a solution. And later we have to learn some important terms. What is the meaning of solvent? Do you know the meaning of solvent? Solvent means which is in larger quantity in the solution, which is in larger quantity and influence or determines or otherwise determines physical state of solution, and determines the physical state of solution. Yes, this is important character. What is the meaning of solvent? In the solution or while preparing solution which is in larger quantity and determines or influences or decides the physical state of the solution is calling as a solvent. Just you will get it. I will give so many examples for this one. After that, one more definition, solute. Yes, you know, in the solution preparation or in the solution which is in lesser quantity is calling as a solute particles, which is in lesser quantity. Okay, always we are writing solution like a one formula. Solution is equals to which one? Solute plus solvent. By mixing of solute and solvent, we are getting a solution. Okay, in the solution which is in larger quantity, that is calling as a solvent. Which is in lesser quantity, that is calling as a solute. And physical state of the solution is depends on solvent physical state. So now just I will give you one example. For example, I am taking 10 grams of NaCl. We are dissolving in 1 liter of water. What we are getting? Solution we are getting definitely. Why? Because after mixing we are getting a homogeneous mixture. We are getting homogeneous mixed water. Before mixing they are in solid phase and liquid phase. After mixing, all the components is only one physical state, which is calling as a homogeneous mixture. So now you check it here, 10 grams and 1 liter, which is a lesser quantity, 10 grams. That's why NaCl should be considered as a solute, and water is relatively larger quantity. That's why we are calling that one as a solvent. Now I am telling one more thing. Solvent only will decides the physical state of the solution. Solvent is in which state? Liquid state. That's why the solution is also undergoes a liquid phase. Always physical state of the solution is depends upon physical state of the solvent particles. And we have to see one more thing. If you take any solution or all solutions, any solution or all solutions should having only one solvent. Having only one solvent. Only one solvent, but may having more than one solute particles. More than one solute particles. Means what type of solution you can take? Containing only one solvent, may solute particle may 2 or 3 like that will be going on. Based on number of the components, we are dividing the solutions into 2 categories. Under that first one I am telling binary solution. Binary solution. What is the meaning of binary? The solution made up of only 2 components. Means that only write down here, the solution which is made up of only 2 components is calling as binary solution. What are the 2 components? One should be solvent, one should be solute. Just I will give you one example. Sugar. Sugar, for example, 10 grams of the sugar dissolved in 2 liters of water. So then we are getting which one? Solution we are getting. That solution only we are calling as binary solution. Why? Because only made up of 2 components. One is sugar, another one is water. Can you identify? 10 grams is the lesser quantity, so we are calling this one as the solute, and which is in larger quantity, that should be considered as a solvent, and which is influence the solution physical state, solvent, because this larger quantity automatically resultant mixture should be in a liquid phase. Okay, now another one, it is nothing but tertiary solution. Tertiary solution. In that table answer is there. Means is a solution which is prepared by combination of 3 components. 3 components. So what is the meaning of 3 components? One should be solvent, 2 will be solute particle. For example, I will give you one thing that it is nothing but NaCl plus glucose plus water. Yes, this is called as a tertiary solution. For example, if you take 5 grams of the NaCl, 10 grams of the glucose dissolved in 1 liter of water, finally we are getting a solution that should be calling as tertiary solution. Why? What is the because of things here? One component is NaCl, another component solvent, which is relatively larger quantity, water. So 1 liter, that's why it is considered as a solvent. Remaining components should be considered as which things? Solute particles. That's why we are telling very clearly, any solution or every solution should be containing only one solvent, may having more than one solute particles. Are you clear? Yes, it's a very important thing. Okay. Yes, now we are discussing about the classification of the solutions based on physical states of the solute as well as solvent. Now, physical state of the solution is depending upon especially which particles? Solutes as well as solvents, which is nothing but which will influence the physical states of the solution? Solvent particle. Yes, whatever physical state having by solvent, that only will be getting by resultant solution. Now, based on this thing, we have three categories. First of all, I am explaining about the gaseous solutions. I will write here type of solution and physical state of the solute and physical state of the solvent, and under this examples. First of all, we will discuss about the types of the solutions based on physical states of the solute as well as solvent. Under this first category is nothing but gaseous solutions. Okay, you have to get some information. Under gaseous solution, what should be the gaseous phase? Solvent should be the gaseous phase. Yes or no? Why? Because the physical state of the solvent only will influence the physical state of the solution. Solution is a gaseous phase, definitely solvent should be in a gaseous phase. Now, I am taking solute particle. Three possibilities. One is gas phase, or may liquid phase, or may solid phase. Okay, if you mix gas in gas, or liquid in gas, or solid in gas, final should be in gaseous phase. Now, can you give an example for gas particle? Lesser quantity of the gas particle should be mixed with large quantity of the gas particle. Finally, the mixture should be gaseous phase. Anybody can give? Air you can take. So why we are telling air is example? In the air we have a lot of oxygen as well as which one, carbon dioxide or carbon monoxide is mixed with which one? Nitrogen gas. Why? Because in the atmosphere nearly 80% is nothing but nitrogen gas, large quantity. In that large quantity, so many gases will be there, so that will be relatively lesser quantity. Now these are in gas, this is also gas. So small quantity is also gas, large quantity is also gas, as well as under comes gas in gas. Now I will give you one more example. It is nothing but liquid matter. Lesser quantity of the liquid should be mixed with large quantity of the gas. Best example for this chloroform. Formula trichloromethane. Chloroform actually it is in liquid phase mixed with air. Yes or no? Air should be in which phase? Gas phase. Like that, if you can see one more thing, it is nothing but solid particle disposing gas. Just you take camphor. Camphor means I think curcuma. Yes, if you take solid color organic substance, if you keep that one in open place, automatically it evaporates. Means that only we are writing camphor in air. Camphor in air. Actually, camphor is a solid particle, goes in gaseous phase, and this is also gas phase. Like this. And we are discussing about the second category is nothing but liquid solutions. Yes, we have to get one clarity here. When we are getting liquid solutions, the solvent should be liquid. The solvent should be liquid. The solute may gas particles or liquid particles or solid particles. Why? Because the physical state of the solution is influenced by only physical state of the solvent. Now, can you give one example for this? Gas particle disposed in liquid, or gas particle, lesser quantity of the gas should be mixed with large quantity of the liquid. Yes, cold drinks. If you take that cold drinks, what happening? CO2 gas in liquid is nothing but water. So actually CO2 is gas. It is nothing but liquid. If you can take one more example also, it is nothing but DO. DO means what? Dissolved oxygen. Dissolved oxygen is what? O2 is already in water, but finally it is appears like a liquid material. Yes, CO2 is gas, and water is a liquid material. These two are comes this example. Now second one, liquid means lesser quantity of the liquid mixed with large quantity of the liquid, final should be liquid phase. Can you give some example? It is nothing but alcohols in water. Yes, alcohols basically liquid phase. This is also liquid phase. After mixing with concentrate, this is alcohol, this is water. Homogeneous mixture is coming. Okay, later, if you can take solid and liquid, we did so many examples. It's nothing but NaCl in water. Yes or no? Why? Because NaCl is the solid, water is the liquid. Solid particle mixed with the liquid particle. Otherwise, we can take glucose in water. Also under comes solid and liquid type of the solutions. Third category we are discussing is nothing but solid solutions. Solid solutions. Under solid solution, what is the specification? The solvent should be solid. Solvent should be solid, but the solute may gas or liquid or solid. Can you give the example? The gas particle, lesser amount of the gas particle should be mixed with large quantity of the solid. Finally, it should be appears in a solid phase. Best example is nothing but hydrogen on palladium. Actually, hydrogen is water, gas. Palladium is water, solid. No chemical action. Why? Because nickel, palladium, platinum are inert metals. They won't respond to any chemical action. Yes, you take a palladium rod on this hydrogen gas will be sticked. Are you identifying a hydrogen gas? No, it's feel like a solid material. So it's falling as a solid solution. But there is no reaction between palladium and hydrogen gas. That should be compulsory condition under solutions. Now second case, liquid particle mixed with the solid. Best example and very well-known thing, it is nothing but amalgams. Amalgams. Do you know amalgams is what? Combination of any metals with which one? Mercury. Combination of any metal with mercury combination is calling as a amalgams. Just I will give you mercury in gold. Nothing but AU. Mercury is what? Liquid phase substance. In gold, nothing but solid. It is calling as a gold amalgam. Like this, if you can take mercury in sodium amalgam, NaHC. There is no chemical action between them, just physically mix it together. And we are taking solid in solid. What is the example for this solid in solid? Yes, we have to mix the lesser quantity of the solid with large quantity of the solid. Final should be solid, but it will not chemically combine. That means we are giving simple example, alloys. Alloys means what? A mixture of metals. Mixtures of the metals. Yes, if you take brass, bronze, these all will enter comes in this category. Brass means what? Is copper and this one zinc combination. Bronze means what? Copper plus tin combination. Anyway, both are solid and solid. Just I will give you one thing. It is nothing but brass. Brass is a combination of copper and zinc. Yes, you can take bronze. Is nothing but copper and tin combination. Anyway, it is a solid, it is also solid. Finally, brass is also solid. Is there any chemical action between copper and tin? No. Such kind of combination solid we are calling as a solution. This is a special character of the solutions. Okay, now we are discussing about the first year of what we discussed under concentration methods. We are discussing once again, but 90% of competitive point of view is asking concentration methods only. You have to observe very carefully. What is that? Concentration. I think you already learned it. Now just start writing the definition of the concentration. Concentration means what? Amount of solute which is present in unit volume of the solution. Unit volume of solution is calling as a concentration. The amount of the solute which is present in unit volume of the solution is calling as a concentration. To express the concentration, nearly we have 9 to 10 methods we have. Among them 4 5 are very important, but even though we have to discuss all concentration methods, under that first I am explaining it is nothing but mass or weight percentage. Mass or weight percentage. Under chemistry, there is no difference between mass and weight. So mass or weight percentage. This mass or weight percentage is denoted by W percentage. Yes, by seeing only we can tell the definition of this one. What is the meaning of mass or weight percentage? The weight of solute which is present in percentage means how much? 100 grams of solution. The weight of the solute which is present in 100 grams of the solution is only calling as percentage of weight. It's nothing but, for example, 5% of NaCl. What is the meaning of that one? 5 grams of NaCl dissolved in 100 grams of the solution. If you take 100 grams of the solution, then definitely how much should be there? 5 grams. That's the meaning of that one. That's only nothing but the weight of the solute which is present in 100 grams of the solution is calling as a mass or weight percentage. For example, to get the formula, I am taking some standard information. Small w grams of solute is mixed with capital W grams of solvent. Then we are getting the solution. How much? Small w plus capital W grams of solution we are getting. Is it okay? Yes. Small w grams of the solute is mixed with capital W grams of the solvent. Definitely we are getting small w plus capital W grams of the solution we are getting. Why? Because solution is equal to solute plus solvent. Now, my question, if suppose you are taking small w plus capital W grams of solution containing how much solute? Small w grams of the solute is there. Small w grams of solute is there. But according to definition, in 100 grams of the solution, how much solute is there? That's only we are calling as a weight percentage. Are you getting that? Yes, according to definition, 100 grams of solution containing how much? That's we calling as weight percentage. Do the simplification. Weight percentage or mass percentage is equal to 2 cross multiplication. It is nothing but small w into 100 by what is coming? Small w plus capital W. So rearrange this one. It is nothing but weight percentage is equal to small w by small w plus capital W into 100. Can we make any theoretical? Weight percentage is equal to, what is the meaning of small w? Weight of which one? Solute by small w plus capital W means how much? What is that one? Weight of solution into 100. What is the formula for weight percentage? Weight of the solute by weight of the solution into 100. Here, okay, everybody knows this one, but here important thing is, what are the units of this one? No units. Why? Because in the numerator and denominator having same terms weights. For example, taking gram, cancel, kg, cancel. That's why. So here we haven't any units. Highlight this point. No units. Is it depending upon temperature or independent? It is independent on temperature. Independent on temperature changes. How it is? In this formula, is there any volume term? No volume term, no effect of temperature on that one. Temperature effect will be shown on the term when the formula will be having a volume terms. Here all are weights. Whatever temperature you maintain, that values will be remains constant. So for example, at 25 degrees Celsius temperature, weight percentage of the solution is 5%. If you maintain even at 50 degrees Celsius also should be remains same. Why? Because by changing temperature, your rho 1 is changing. Because no volume term, that's why the values will be remains constant whatever temperature you maintain. That's why the weight percentage will not have any units, and as well as it is independent on temperature. So now we are discussing about the second term. It is nothing but volume percentage. What is the formula for weight percentage? Weight of the solute by weight of the solution into 100. Now we are discussing about the volume percentage. Volume percentage denoted by which one? V percentage. Yes, you know very well. What is the definition of this one? So it is nothing but the volume of solute which is present in just tell me 100 ml of solution. This is a convenient when solute and solution should be liquid phase. This is convenient when solute and solution should be solid materials. Why? Because we are expressing them in grams. So now we have to take small v ml. What is the formula? What is the definition? The volume of solute which is present in 100 ml of the solution means, for example, small v ml of solute is mixed with capital V ml of which one? Solvent. Then we are getting small v plus capital V ml